Hi, welcome to part 4. So before we proceed, just to give you a quick heads up about this new IDE launched by Google. They call it anti-gravity. I gave it a try, but I found a few weird things. For example, the notebooks we have been following for this tutorial, I wasn't able to open them. It keeps on giving this error. I thought there are some issues with the Jupyter extensions which I have installed by the default marketplace, that is OpenVSX of this anti-gravity IDE. Then I switched it to the marketplace of default VS Code. You can do it here. Go to this editor and you can switch it to the VS Code default marketplace. You need to change both of the URLs here. But still, even after installing this Microsoft default Jupyter extension, I keep on getting the same error. The good thing is that you have this Gemini 3 Pro model access for free. Unfortunately, I cannot use it with my notebooks. Another thing is that VS Code has this really nice feature of tunneling, where you can actually connect to remote machines using tunnels. It's not like SSH connections, but I have spoke about the VS Code tunnels in another video. I will drop a link about it. That's not also there. Also, when I connect to SSH host, not the WSL, but the SSH host, it says it cannot initialize its AI components, something like that error I also got. I think I'll have to wait for a couple of more releases until that it gets more stabilized. Okay, back to our topic, part 4, augmentation. So far what we have learned is just a quick recap. Data indexing. Let me hide it. We don't need to see this. In the RAG pipeline, the data indexing, the part 2, part 1 was about introduction. So we learned about data cleaning and making our data noise free. We saw various chunking strategies, embedding models, how to set up your vector store. And also we saw the various indexing parameters when creating your vector store, cosine, similarity, or Euclidean. Then the retrieval part, we saw how to efficiently retrieve. There are straightforward dense retrieval. You just fire your query on the vector store and you get some results, top k results. And then we have this hybrid along with this BM25, which I was using. You can use your own as well. Then query expansion. You may think of assigning or refining the query that is coming from the user so that you have better results. And there we saw that acronym handling, contextual rewriting, and having multiple queries generated from a single query. So that way, when you fire such a query on the vector store, you get better results. Then various re-ranking techniques. We did re-ranking using a model in neural networks, and also we did some context filtering. Now we are actually here, the augmentation. So what is augmentation? So have a look. Augment means expanding something, adding something on the top. So it literally translates, or it literally means in English, the action or process of making or becoming greater in size or amount. So you are making something bigger. So that's exactly what augmentation is. So you have your chunks retrieved so far in your RAG pipeline. Now you want to augment. Augment what? You want to augment the chunks along with some user prompt before sending it to LLM. That's the next part, by the way. We are still discussing augmentation. Technically, we haven't reached to the point where we need to speak to AI so far. But we keep on saying like how to send the queries to the LLM in various parts. I have demonstrated just a small part so that our demo looks complete. But that querying using Grok client, for example, in my notebooks, I was using Grok. So that part actually comes into the generation. But as I said, for the sake of keeping the demo complete, I have always placed the small cell at the end where it sends the request to LLM. But that is to be discussed in detail in the next part. So augmentation, what all we are going to discuss in this part. As you have already seen, augmentation means making something bigger in its size. We have our retrieved chunks and we want to make it bigger in size. How? By combining it with some prompt. So this prompt and context combination will be sent to LLM at the end. So that's all about augmentation. What we are going to discuss in detail is the prompt templates. So the prompt, like basic question answering template, instructional template, where you want to give LLM some instructions like do this, after that do this, and so on. Citation-focused template, where you want LLM to include the sources of the information, and then chain of thoughts. It's like deep analysis kind of template that we all going to see, and along with the role, query, those things in the template, and we will combine this template with the chunks which we have retrieved. And in this section, we will call it context. Chunks or context are the same thing. So whenever I say context, in this video, you mean chunks that we have retrieved from our vector store. Next, we will discuss the context integration strategies or chunks integration strategies. So there can be simple concatenation, numbered, metadata enriched, summarize. For example, you have chunk 1, 2, 3. Do you just want to combine them like concatenating two strings? Or do you really want to sort them based on their scores? Or you want to sort them by the index they exist in vector store? So such things which we will be operating on the context. Again, context or chunks. We will see a complete augmentation pipeline in execution and also some advanced context window management. And this part is really, really important. Believe me, guys, whenever we say about augmentation, we consider it to be the simplest step in our RAG pipeline, but it is not, especially because of this alone part, context window management. Here we will see what is the difference between context window and the memory, and we will see how to fit our context plus prompt into the context window of an LLM. And at the end, because of this consideration, how the cost of overall request execution is affected. The more tokens you send to LLM, more costly it would be. So as always, let us jump into the code. To discuss about the part 4 of augmentation, I have created a new notebook as always for other parts. Setup prerequisite. So there are some imports. Let me run it. And then, so next, semantic chunking function. So the previous steps in our RAG pipeline are necessary to be executed. I am not going to go in depth. These are just the copy pasted cells because they are needed. Once again, where are we? We are in the augmentation stage of our RAG pipeline. So we need data and its indexing, chunking, retrieval, and a vector store to proceed with augmentation. So these are just the prerequisites to execute further in our notebook. Created 10 semantic chunks. So there were various strategies how to chunk it semantically by paragraph, word, this and that. You can go and see this part, data indexing, and then create the vector store. Let me execute this as well. So we have 10 chunks created. Now I need this function for the retrieval. So this step, we are in the retrieval now. Again, this has already been discussed in the part 3. Just let me execute it. So just that this function is available in the memory to be executed. That's why we needed all these prerequisite steps. And the grow client, although this speaks to LLM, or this is specifically the AI part, but to complete the demo, I always use and use this grow client to speak to LLM. Although that part belongs to this stage, the generation where we actually go and speak to LLMs. But as I said, to keep all the demos end to end, focusing of course on the core thing which we are going to discuss, I keep this LLM part in very short form. Now we are into the augmentation. So prompt template design. So there are various kind of prompt templates which you can design according to your application need. Common prototype templates patterns are like basic question answer type, simple question and context format, instructional, citation focused, or chain of thoughts. Let us get into the prompt itself, that will make the things clear faster. So this is an instructional template. You are a helpful assistant answering questions about remote work policies. So to give you a recap, the data in our case, we made a dummy data which actually is a remote work policy of a company. Going back here, instructions are use only the information provided in the context below. Context means chunks. So chunks are created out of this information. Yeah. And if the answer is not in the context, say, I don't have enough information to answer. I will keep on recalling the facts which has been discussed in the previous steps. For example, vector store, no matter it has the exact information asked by user or not, it will always return you some chunks. Of course, those chunks will be having a very bad score of semantic similarity. So here it is important. If the answer is not in the context, say I don't have enough information. So you will have some chunks, whether they are matching or not. Now, before when you send it to LLM, you are calling or you are asking LLM to do this. You say, I don't have enough information because the chunks were totally unsimilar to the user query. Be concise and accurate. Cite the relevant section when possible. This is kind of Jinja template here. You just put in the context and the question. So this is user query and these are chunks. So similarly, I have a next citation template. You are a policy assistant that provides accurate answer with proper citation. I need to inform user what are the sources where this information came from. Answer the question using information above. Include citation in the format like source. This information, if this information is not available, clearly state this. So this is kind of trust building between the AI agent or AI application with the user. User is clear about where this information came from. Template 4 is about chain of thoughts. You are an analytical assistant that explains your reasoning. So it will explain the reasoning as well. When it is searching, it will tell why it is responding like this. So first, identify the relevant information from the context or from the chunk. Explain your reasoning step by step. Whenever you use your coding assistants, you see those messages coming. Okay, now I will read this file, I will read this function, I can see this variable is missing, I will define. So such reasoning is called chain of thoughts. One thought, then that triggers another thought, that triggers another thought. So this process is called chain of thoughts. And then at the end you get some response embedded here from LLM. So here I'm just for the demo purpose, I'm providing some dummy chunks here, although in the cells afterwards we will be retrieving those real chunks from the vector store. But just that how the Jinja template replacing of the context and query works here, just to demonstrate that. So it will look like this: context this, question this, and if I expand it, you will be able to see the full template. You are an analytical, for example, chain of thoughts template. You are an analytical assistant that explains your reasoning. Context information is chunk 1 and chunk 2 or chunk 3, 4, whatever top K value you have defined. and question was the user query that has been kept here, and the instructions. So the Jinja template, if you don't know, you define a string and define some placeholder like things. It's not only placeholder, you can do much more things with such templating stuff, but they are just placeholders, you can say, and you just replace them by the exact name of these variables, if you can call them. So here you see that context and query has been replaced with the sample context or sample chunk 1, chunk 2 here, and the sample query. That's it. Pretty simple. The next would be the context integration strategies. Now we have defined a prompt. Now how to integrate our chunks? Here what we did, we just went straightforward and integrated our chunks and queries into various kind of templates. But actually there are strategies behind it. Simple concatenation. What we did, chunk 1 and chunk 2. Why we are mentioning this word at all, chunk 1 and chunk 2? What if I put this string here and after that I just concatenate here? So such things which we are going to discuss in the next cell. Simple concatenation, join all chunks with separator or maybe no separator, fast and preserve all details, may exceed token limits. So there might be duplicate information. While creating chunks, you also define overlapping tokens or characters, so that may also increase the size of overall tokens which you are going to send to LLMs. Another would be numbered or labeled context. Add identifiers to each chunk, like chunk 1, section this, topic this. For example, in our previous cell, we have included this chunk 1 and 2 numbering. Strategy 3 would be metadata enriched context. You put more metadata, like what is the source, what is the date, what was the topic, what was this document about, what was the document name itself. So such metadata is really helpful at the end for the user when it comes to citation like templating. Provides additional context to LLM, useful for multi-document retrieval. Next is strategy 4, summarized context. You summarize using LLM. So there would be 2 calls for LLM. For example, you have chunk 1, 2, 3, 4, 5, 6 retrieved from vector store, and now you don't really want to increase the token size. You can send all those chunks to LLM first to summarize them, and then finally integrate those chunks with your prompt and send it again. So that's all about it. Hierarchical context is like if you have numbers and if you have various sections named like 1, 1.1, 1.2, so you can order your chunks or context in that way. So that helps LLM to hierarchically analyze the information provided and build a response accordingly. So organize chunks by relevance of topics, present most relevant first, and this helps LLM prioritize information. So here are various functions which you can do. Strategy 1, simple concatenation. So there are retrieved results which are coming from the vector store. So if I go down first, what kind of retrieval we are performing? We are doing a hybrid retrieval. So we have already created the vector store in the beginning of this notebook, which I already executed. Now we are performing a retrieval. So this retrieved set of chunks, basically we are passing it to our various methods, various types of contextual concatenation. So this is simple. Put one chunk after another using some, let's say, separator. In this case, the separator is like this, dash dash dash. Numbered context, metadata. So basically whatever we have discussed here, there are multiple functions performing the same thing. So let us try to run this. Just press this run button and we will see the output, and that will say its story by itself. So available strategies in our cell 5. query for the demo. The query is, what are the internet speed requirements? So raw retrieved results are like this. Let me expand the output here. So there are two results. The chunk ID, you see there is lots of metadata that our hybrid retriever has retrieved from vector store. Hybrid score, vector store, BM25. If you recall from previous step, we did BM25 and vector score combined together to calculate the hybrid score. Metadata, what is the topic? So I have multiple chunks as a result retrieved. So join chunks with separator. That's our very first strategy. What we are going to do, put one chunk here, use separator, and put another after here. That's it. Not so advanced, right? Now strategy 2, numbered context. You put some number as well this time. Again, to prioritize the response, prioritize the chunks, to help LLM to prioritize the information, which one to keep first, and organize it hierarchically. Strategy 3, metadata enriched. Here you will see more and more metadata which we are going to send it to LLM, so that all this metadata helps LLM to understand what this information is about. This is about remote work policy. Then you have some topic, so you have some topic here as well. So this overall helps LLM to structure the response. For example, if multiple sources are referred or multiple topics has been referred for answering a query, when you send such chunks coming from multiple topics or sources, so LLM can structure the response according to this context, which is coming from multiple source and topic, in a way that it clarifies user, okay, according to the policy it says, but there are a few exceptions, so that topic would be exceptions. So this metadata is really important. I would say this is the best technique, the strategy 3, to send all the metadata to LLM. So next strategy is hierarchical context. So hierarchy you can maintain by sorting the chunks based on their scores or based on the chunk numbers. So this helps LLM prioritize important information, which one to keep one. For example, in this case, the score really makes sense. So higher score, higher hybrid score means that this chunk is more likely to be semantically similar to the user query. Although I call it semantically similar, but we are using the hybrid retrieval here. So it is 70% score from the semantic similarity, that is coming from the dense vector search, and 30% from the BM25, that is keyword based search. So if you have missed this retrieval part 3, please go and watch it. We have discussed that in detail there. Okay, back to the topic. So we have different strategies for our context integration here. So just to mention that how, for example, here the metadata enriched context, these chunks were created. Let me put it here in the split window. You see this first chunk, the question was, what are the internet speed requirements? Basically, this is a work from home policy, remote work policy of a office, of a company, and user asked, what are the internet speed requirements? So as a part of hybrid retrieval, we received 2 chunks with some metadata information, and you can match it against the content. Which chunk it is? Eligible employees must. So where it is, just copy this thing and try to find it here. Eligible employees must. So it is somewhere here. So it chose this chunk until 5 Mbps speed. Where it is? 5 Mbps here. So this chunk is from here until here. So this is your first chunk, and similarly you can find the another chunk here. And have a note that We already embedded the metadata information in our previous step. So remote work policy, it was chosen from the heading, kind of heading from our text information. And then the topic, the subtopic, eligible employees must. So this is just the section of the chunk which was considered to be the topic. So it was taken care while creating the vector store. That's where it is coming from. And similarly, you can search the second chunk as well, just to give you an insight that where these chunks are being created. So far we have discussed in augmentation. We have some chunks. We need to augment our chunks with some prompts before sending to LLM. We saw that how to define our prompts using various templates, and then how to integrate our various chunks. We saw various strategies here. So far in this part of augmentation, what is augmentation? What we are augmenting? We have some chunks which are retrieved from vector store. We need to augment it with some prompts. We need to make our chunks or context bigger with some additional information, that is prompt. And in the beginning, we saw how to design our prompt using various templates. After that, we saw how to integrate our various chunks. You might be retrieving more than one chunk, so how to combine them together. So you have two parts already structured. At least you would have understood how to structure your two parts. One is prompt, another is context. Now you need to combine them together using various strategies in prompt building and different strategies which we saw in the context integration. So here in this cell, what we are going to do is we are going to see the complete augmentation pipeline. So this is the function which will take your context strategy, one of the context strategy and one of the template type, and it will combine both of them, and it will give you the question built up or a query built up which is ready to be sent to LLM. So without going into each and every line of the code, let me run it. So in the output, we see augmentation demo of end-to-end pipeline with citation. Let us have a look at these lines. The context strategy which we are going to use for the demo is the numbered. So we will sort our chunks by numbers, and the template type is citation. If you remember from the first step where we were defining various kinds of templates, so we are using the citation prompt template. Just combine both of them and you have your final output which you can send to LLM as a user query. So here are a few points to be noted when it comes to citation. Builds user trust or credibility, allow verification of the information, that's obvious. Reduced hallucination by grounding answers in sources. So that is very much important for LLM to reduce hallucination. It doesn't assume something that doesn't exist. So when you say citation, you provide the information about the sources. Enables traceability for compliance and auditing, very important from user point of view. Now helps user explore related information. Because we have used the template type to be citation, the LLM response will include the sources, and then you can further explore those sources for your query. Okay, back to the output which we have in our end-to-end pipeline. Again, the query was this thing. The hybrid retrieval took out the three chunks. Let me expand the output and go to the beginning. Three chunks. Applying context strategy, numbered. Applying template, citation. Context prepared, that many character. Final prompt after the citation prompt integration is resulting to that many characters. So this is your final augmented prompt. Now here you can correlate why we call this augmentation. So you had some user query and you had some chunks, but there is additional information at the end and in the beginning. So we are just a step behind, sending all this augmented piece of text to LLM, and hopefully that will provide us with some answer. Basically that's a generation step, but we will execute it briefly in this part as well. But before we really try to generate any response from LLM using such augmented piece of text, let us jump into this very important thing that is called context window management. So whatever we have seen is kind of flat approaches. You have manipulated the text, whether it's context or chunks, put it like this, use some separator, things like that. And again, the prompt templates, these are also some flat text which you are going to send, but there is no intelligence kind of thing. At the end, you are going to send this big piece of information or text, that is final augmented prompt, to some LLM, and there are some limits. The text, the amount of characters, the amount of tokens to be specific to the LLM. You cannot make it as big as you want. So that's all about we are going to discuss in this context window management part. Before we proceed, there are sometimes confusions that context window and the LLM memory are same. No, it is not. So context window is maximum tokens the LLM can process in single request, and LLM memory is the conversation history. So in a complete RAG chatbot, your context window must fit. Context window is basically in a single request, how many tokens can a LLM process. What is token? Token is not word, that we also have discussed in previous parts. So how many tokens a LLM can process in a single request. You always don't really want the only prompt which you have augmented like this. You also want sometimes to include some history, but that altogether, the history, this prompt, the augmented prompt should not increase or should not be exceeding the context window size at any time. And every other LLM is having different context window size. So what is the problem here? You would have already identified. Every LLM has a context window, and that is pretty much fixed and limited. For example, GPT 3.5 turbo model have 4,000 around tokens of a context window, which means the total token in your prompt along with additional information from the history of the chat, if you are willing to send, should not increase 4,000 tokens. And similarly, we have different limits for different models. So when you retrieve many chunks and have long documents, the combined context can exceed this limit. That's what I said. So API error, request rejected can happen. Truncated context, LLM only sees partial information if you send more tokens than the context window size of an LLM. So these many problems can occur. So you understand what is the real world challenge here. What will happen if you increase the context window size? Now, what are the strategies to mitigate this problem? One is truncation. Simple and fast. Go and iterate through your augmented prompt until the context window size has reached and truncate everything else. Simple, straightforward, but it has got problem. May lose valuable context. What if the part you truncated was having something valuable? So truncation strategy is very simple to implement but have a significant problem. Summarization can be another strategy to fit everything in the LLM context window, where you can use another LLM before sending any information to LLM. That partially we saw while in one of our context integration part, where we were summarizing the context. So we had 4 or 5 chunks and we asked LLM to summarize those 4 or 5 chunks into a crisp information to decrease the size of tokens. So similarly here, if I get back to the context management part, so similarly here, for not only for summarizing the context or chunks, multiple chunks, you can also do a summarization on overall augmented prompt as well. So this condenses multiple chunks into the key points, maintains semantic meaning in the less space, very effective it is. So this adds latency also. Not everything is good about it, of course, because there is an additional step to speak to LLM for the summarization and may lose specific details or nuances. Now, when you send it to LLM for summarization, you cannot control it, how it summarizes. There might be some keywords which LLM might omit, but you really want this in your prompt before sending to LLM for final response. So it has got its own caveats as well. So next is chunked processing. This is nothing but once you have retrieved your data from the vector store, this is further categorization of various chunks in batches and send them to LLM in different calls, different batches to LLM, and at then combining the responses received from various responses. So using this strategy is beneficial when you have a significantly big prompt to be sent to LLM. But of course, this will come up with some complexities, how you are going to divide your prompt before sending LLM, and what is the strategy afterwards for combining the various responses, and how to keep track of the responses, that these many 10 responses were for this context or this overall prompt. So it comes with some complex implementation requirements as well. The next is smart filtering. Basically, it's kind of pre-processing before sending it to LLM. You summarize, you remove redundancy, duplicacy in your prompt, you make it more crisp. And this is very much similar to summarization of the overall prompt. Now we have our coding demo here. So what we are going to implement is we will truncate and summarize our prompt. So we have this estimate tokens method, which is basically dividing it by 4. This is the rough approximate. Real tokenization depends on the specific tokenizer used by LLM that we have discussed in previous part. For example, tick token is used by GPT models by OpenAI. But what we are going to do is we are sending some text and we are just returning a fixed number. Then we have this method called manage context window. This is intelligently managing the context to fit within LLM token budget. So whenever this max token window is exceeded, so it makes use of this function. So what are the tokens in your prompt and what is the max token count, and whenever it basically exceeds, your prompt exceeds this token count, it basically applies this strategy by default, or if you send some other strategy here. But it handles only 2 strategies, truncate being by default. So implementation is quite simple. Max token is this thing, and the retrieved results, this function will call or count the estimated tokens. If they exceed this max token, apply this strategy, either truncate by default or the second one is the summarization. Of course, in summarization there is additional step which you can already see it here. You need to speak to LLM, yes, to summarize the context. If I go to summarize context, that is implemented in our one of the previous context integration strategies. So this function is useful here. So we are sending our retrieved results for summarization to an LLM group client, and have a look at the prompt. Summarize the following text concisely, preserving key facts and details. And here you go. So yes, this manage context window function is doing pretty much everything for you. And what we do next, we execute and analyze the output. I have executed it. It took a while. It took not a full second, but it took a while because it executed first of all both the strategies which we are going to see in the output. But for the second strategy, it was to contact LLM in the cloud. So let us have a look into the output. This is a context window management demo. That's very much clear. Thank you. And the scenario is we will retrieve 5 chunks, but they might exceed our token budget. Then we need to apply our strategies, either truncation or summarization. I think it is both of them. What we are going to, it's not either, this is both of them. And so strategy 1, truncation. So truncated to 4 out of 5 chunks. We were sending 5 chunks to the function, but according to token size, which we were passing to be 500. If you see here, the max token I was sending 500. In the function, the default was 2000, but with the 2000, it was including all the chunks. It was a big context window. So I reduced it so that we can see something in demo that is working. Let me go back to the output here. Yeah, so 500, it took 490. So it automatically calculated that I can fit that many chunks, but still the 10 tokens are still remained. But the next chunk was bigger than 10 tokens. So it was calculated like this. It won't fit 500 out of 500. So token saving is 116. So next chunk was of at least this size. So it cut that through so that overall tokens don't go beyond 500. Result, keep 4 most relevant chunks and use cases when you want to preserve exact wording of the top chunk. So we have the numbered chunks, and the top chunks will be counted in the user query or user prompt before sending to LLM. So number 2 strategy is summarization, that is to compress context, or to be specific, summarize the context, summarize overall user prompt using a LLM. So here we have done, context was too large. It was having 608 tokens, which was very well above our token limit, or to be specific, context window size. And then we called LLM with the prompt what we have seen, like summarize this, keep the key facts intact, and the things like that, which we have seen already. Summarize to 242 tokens. Let us have a look, how effective it was. Now I don't really know what it has cut through, but it was very effective. From 608 tokens, it reduced it to 242 tokens. But one more important thing to understand here would be, I was thinking, if your token count is not like 608, but it is something like 6,000 something, and even after calling LLM to summarize that, still is bigger than 500, then you might need to call LLM again for the summarization. So something like again and again zipping the zip file in a hope to compress it to fit a specific size. So, but in our case, only one time calling of the LLM worked and bring the overall user prompt under the limit. But if it is the case, then you can really say it to the prompt that keep the overall size of the response under this limit. So such things you can put it in the prompt. Although I believe that's not exactly guaranteed, but that will help you to achieve the limits faster rather than calling LLM multiple times. All right, so we have a result, and the key takeaway: truncation, fast, preserve detail, that we have already discussed, and summarization, compress all info, but adds latency, that we are pretty much aware of it. Yeah, so the next thing, the important one, comparison of different augmentation approaches. And here we are speaking about the money. If you have the real life AI application and users are using it, everybody is concerned about spending less. So how we can do that? We have discussed several strategies. We have different prompt template. We have different context integration strategies or chunk integration strategies. And now we have seen the context window management as well. So in this section, let us compare how different augmentation strategies affect final answer quality. And we briefly use generation here. Yes, the generation part, again, this part. Although we have been using this Grow client, let me mention it again. That's not all about vector store or retrieval or augmentation. That's the actual AI. That's come under the generation part. But for the sake of demo, I keep on using it and demoing you guys. So here we will briefly use generation once again. Let me run this and see what this cell produces. It ran. It took exactly 1 second, although I think it's not that exact. It is printing here. But anyways, we are interested in the output. Let us analyze it. Comparative analysis of augmentation strategies. So the query was, what are the internet speed requirements for remote work? The very same query which we have been using so far. Now the testing, the strategy for 2 parts. Your context or chunks, how they have integrated, and the prompt template. So this is the simple, I think by that I mean here is combining them with some separator, combining multiple chunks with simple separator. And the basic prompt was Q&A type of the prompt template, the very first one. And we have some results here. The internet speed requirement for remote work, 25 Mbps download, and this. So this is the final result that is coming from LLM. Answer is of 25 tokens. Token used were total 397 input, 25 output, 422 token exchanged. So this is one type of strategy which we have used. Simple concatenation of the chunks and the basic template. Now I have various examples in this cell. Without going into each and every one and explaining, let us go at the bottom for this table. It gives you an idea how important is to have your RAG pipeline efficient. That was the thought behind doing this series. It directly impacts the overall cost of your AI application. So have a look at this token usage and cost comparison table, which tells you the overall story about what was the expenditure or what could be the expense of the day using various strategies. The first one is simple numbered metadata, which tells you about the strategy used to combine various chunks. And another one is the prompt template which you have used. So the cheapest is simple plus basic, simple separator concatenation with basic template, but that might not be the most accurate one. So these are the dummy tokens which you have already seen. The token count was kind of returning the fixed number. That might not be the thing, but what I am trying to highlight here is you provide or you develop some kind of mechanism to calculate such costing based on different strategies or configurations in your AI application and overall cost of a day, also using various models. So let me summarize what we saw in our part 4 of augmentation. That's pretty much inside this RAG buzzword. So we saw how to define your prompt template, and also we saw how to do the context integration. Context, which we referred here to be the chunks, how to combine the chunks. So you combined your chunks using various strategies and you created your various prompt templates. Now this is the time to augment, and you augment your combined or integrated chunks with your prompts, and you can send it to LLMs. But we also saw in this video how to fit your overall user prompt in the context window. And we also saw the importance of a kind of small tool which can compare the cost using various strategies in your augmentation part. I hope you have been enjoying the series so far. We are at part 4, augmentation. In the next part, we will see the generation, which is actually the AI part, where the AI comes into the picture. We speak to AI, we send our user prompts. So stay tuned and see you in the next.